Hi, calculus kids. This is week 15, Tuesday. I thought I did a really bad job at explaining part D of this, so I apologize. I'm actually going to do a better job doing this. So I'm going to go back to part B and re-explain what I meant with this. So let's just go back to part B of this question here. So for part B, it is asking you to find the second derivative of the dy over dx. Now, you know that dy over dx is going to be equal to 2x minus y. So your second derivative is going to be the derivative of 2x, which is 2, minus 1 dy over dx. So then you know that from the initial equation, dy over dx equals 2x minus y. So I'm going to plug it in here. So I have 2 minus 2x minus y. So that's the same thing as if I distribute the negative, 2 minus 2x plus 1. So that's your second derivative. Okay, so part B says determine the concavity of all solutions. Now, concavity is referring to the second derivative. Remember in Unit 3, if the second derivative is greater than 0, then that means your graph is concave up. Similarly, if f double prime of x is less than 0, then it is concave down. And then remember, f double prime of x, you set it equal to 0. That gives you point of inflection, which basically you have to test the point on the left side and the right side to determine if it's going to be concave up, coming down. So then looking at this here, given the fact that it says in quadrant 2, when I initially did the video before, I mistakenly labeled it incorrectly. I apologize about that. This is actually quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So it's really just kind of like a counterclockwise, but I went clockwise, so that's incorrect. So quadrant 2 is in this section right here. And in this section, if you look at the x values are obviously less than 0. Y values are greater than 0. I mean, if you think about it, if I were to pick a point right here, that point will be x equals -1, y equals 0. If I pick a point up here, x is -1, y is 2, okay? And so let's assume we're going to be using that point with -1, 2. Let's plug it in here. So dy squared dx squared equals 2. 2 times -1 is going to give me a positive 2 plus y, or plus 2, y is 2, which is going to give me a 6. So if I look at this right here, that is greater than 0. 6 is greater than 0. So then I can say in quadrant 2, when x is greater than 0 and y is greater than 0, dy squared over dx squared is greater than 0 for all solutions. Therefore, and with therefore on the test, you could do 3 little dots, which means therefore, so you could shorthand it. Therefore, all solutions in quadrant 2 are concave up. And that's how you can describe it for part B. Okay, so now let's take a look at part D, because I don't think my explanation was as clear as it could have been. So for part D, it says find the value of a constant m and b for all of which y equals mx plus b is a solution to the differential equation. Now, in the last example, you know dy 2 over dx squared. Well, actually, we don't need this one, just kidding. We will need the slope. Your slope is going to be dy over dx. And in part, actually, in the example they gave you, that's equal to 2x minus y. So that's the first part. In addition to that, it's also given to you that y equals mx plus b, okay? Well, if I were to find the first derivative of y, that's the same thing as saying the first derivative of y is y prime, which is equal to dy over dx. Well, m, as you guys know, is a constant. B is also a constant. So the derivative of m of x is just a constant. So it's just going to be x. I'm sorry, it's just going to be, your x is a constant, I apologize. It's just going to be plus 0, which is what b becomes with the derivative, which is just m. Okay, so looking at the first formula, because we have two right here. We have the first formula here and the second formula right there. With the first formula, dy over dx is another way of saying m is equal to 2x minus y. And looking at this y right here, you know for that y, it is equal to mx plus b. So let's go ahead and replace that. So I have m is equal to 2x minus y, mx plus b, which is the same thing as 2x minus mx minus b. And now what I can do is I can factor out between the 2x and the mx. I can factor out x, which will leave me with 2 minus m minus b. Now looking at this, m is equal to this part right here. The second equation's m is equal to this part right here. Let's set those equal to each other. So I will have m from the first equation equals m from the second equation. And for the first equation is x, which is x parentheses 2 minus m minus b is equal to m plus 0. Well, let's go ahead and see if we set them equal to each other. I know that my negative b is going to be matching my m. And then the x 2 minus m is going to match the 0. And with the 0, you could put an x because 0 times x is just still 0. So you have this piece right here equal to 0 and m equal to negative b. So then m equals negative b, and it's given to me that 2 minus m equals 0. Well, if I move the m over to the right side, I have 2 equals m. Well, if m equals 2 and m equals negative b, well then doesn't m equals negative b equals 2? Which means b equals negative 2. So in this situation, it's a little bit of a play on your algebra skills. So find the values of m. Well, your m is going to be equal to 2. Find the value of b. Your b is going to be negative 2. All right, you guys. So that basically concludes part B and part D of this example. Make sure you guys answer the following questions on my Google form. And that's basically it. I hope you guys have a wonderful week, and I'll see you guys on Wednesday. Take care.